Right, let's give it 1 or 2 more minutes, Roland, and then we can get things started. All right, I would say let's kick things off. I'm super excited to have Roland Jones today on the show, a solutions specialist at Altair, and today we'll delve into Altair RapidMiner, which is a powerful data analytics tool and AI platform that connects siloed data, unlocks hidden insights, and accelerates innovation with advanced analytics. I've personally, as I said to Roland before, never used that tool, so I'm super excited to see what we can do with RapidMiner. So without further ado, Roland, the stage is yours.
Perfect. Thank you very much, and thank you very much for having me back. So welcome, everyone. I've got a couple of slides just to kick it off, and then we'll dive straight into the software, and we've probably got about 40 minutes worth of content to get through, so I better get started. So first off, we'll just start with kind of what Altair RapidMiner is, for those perhaps not as familiar. And I think it's important to remember, whatever industry or whatever role we might be in, usually we end up in this kind of starting point where we have a lot of different data sources. Maybe we've got some Excel documents, maybe we've got some databases or some reports, some cloud platforms, whatever it might be. And these are probably spread all over our company. We've got to manage those, do something with those. And ultimately, where we're wanting to get to is to that output. We want to get to produce our final reports, our documentation. We want to build apps. We want to have data-driven actions, maybe dashboards. But then it's what happens in the middle there. How do we move as quickly as possible from all of our different data through to insights? So how do we make that happen? And where Altair comes in is generally at the first stage. Where we start is building what we call a universal data overlay, or perhaps connected data fabric. This connects to a lot of different data sources. It can be structured or unstructured data. We're also vendor neutral, and this is backed by knowledge graphs. So it's a new technology which I really recommend looking into. But then we have a complete second layer, which is an AI and automation tool set that's not just designed for maybe the data scientist, the coder, but also for the domain expert, the engineer amongst us, perhaps, who's more focused on the domain we're working in, and less so the kind of technology per se that we're using. So together, these kind of make Altair RapidMiner, and these bring a number of different benefits around kind of breaking down different data silos, making more data available, accessible, making sure that we can have impact with it. But what we're kind of particularly focused on today is that second layer, that complete AI and automation tool set. And what that brings is a number of different things. So the coders amongst you get things like VS Code and Jupyter Notebooks, kind of different Python environments, centrally managed Python environments. You're working off the same page. We also get access to things like generative AI. Of course, we've all seen what tools like ChatGPT can do, but how do we make that impactful? How do we work on our production data? We then have these low, no-code, block-based workflows where we can build data preparation and predictive analytic pipelines. So again, without any code required, in a completely visual environment, we can be really impactful with data analytics. But what do you do once you've built that? Well, then you need to deploy it. You need to make it operationalized. So that's where we have an ML ops kind of package where we can monitor how it's performing, whether the pattern of predictions is changing, how the accuracy is doing when it's in production. So again, we have that kind of capability built in there. If we want to make it even easier, we also have Auto AI. So we'll see that in a bit as well, where you bring a data set and then you can get insight. So not even needing the workflows, but just clicking through a series of menus. And all of this is ultimately built with a kind of collaborative nature in mind. So it's not just me working on myself, but I can share it with colleagues. I can share it with someone who's perhaps done this sort of thing before. We can reuse different parts of of our processes. So it's really powerful for getting a team together working in a kind of data analytics and data science environment. So to kind of show off the software, we'll be using Altair AI Cloud today, which is a SaaS product which can be delivered through the browser, but it can also be installed on premise. So what we'll be doing is looking in a kind of predictive maintenance context. So for perhaps those of you not as familiar with that terminology, we quite often will have kind of reactive maintenance where we fix something when we're seeing something wrong, maybe there's smoke coming off it, or perhaps to mitigate against that, we do some form of regular maintenance after a certain number of hours. So maybe after every 1,000 hours, we take something apart and then we put it back together again. So predictive maintenance is trying to be a bit more data driven. We're taking what's happened in the past and trying to predict what's going to happen in the future, because that allows us to make better decisions. So we're trying to predict what machines will fail when, where we should prioritize our maintenance. And it means that we can ultimately minimize then the amount of maintenance we need to perform, because we're making those best possible decisions utilizing data and AI. So we've got kind of three main things that we're going to try and do. So the first is simply bringing all of our data together and visualizing it. You may be asking yourself, that's not really AI, but of course, this is still a big hurdle that many people and organizations have to overcome, and we'll be showing how we can make that easy. We'll then be looking at how we can predict which machines will fail, so using historical data to predict which machines will fail in the future. So then we can do things like what if scenarios, we can plan maintenance more effectively. And then finally, we're looking at how can we provide operator support. So we've all seen, again, tools like ChatGPT, but how do we make that so it's useful to that maintenance engineer or perhaps that shop floor worker? So we'll see how we can utilize generative AI and AI agents to build those sorts of tools. So again, just to kind of summarize, we'll be kind of starting off with some data preparation and visualization. And then we'll be moving on to some automated analysis. We'll also be having a look at some text analysis. So looking at how we can take free text, which I certainly know engineers, we end up dealing with a fair amount of in documentation and reports and things like that. So how can we mine that for more information? How can we use generative AI as well? And then finally, we'll be looking at kind of building agentic AI systems. So with that, I'm just going to change my tabs and just move over to Altair AI Cloud. So here I'm inside my project. So you can see I've actually already got some stuff here just that I built in preparation. But just to give you a little bit of a tour, we have access to our files here. So you can see here I've already got some files that I've already prepared earlier. We also then have connections to our enterprise systems. So this could be access to a database, or it could be access to a generative AI application, which you can see I've got here. But what we do is we provide these kind of managed access to all of these different systems and many more as well, which means then it can be set up by IT. It still conforms to good governance practices, but that means the users can leverage this simply within their kind of workflows and their processes. So we've got that. We can interact with things like Jira and Confluence as well. But right now I'm going to move back into my content and we're going to get started. So we can build a variety of different things here, and we'll be touching on some of them later. But to start off with, perhaps what RapidMiner is most well known for, I'm going to start in Workflow Studio, and we're going to call this data prep. So what I'm going to be doing is creating this low-no code workflow. Oh, that should have just popped up. Excuse me. Just go again. And there it already exists. So we'll just go one more time. So what we're now doing is creating a new workflow that we're going to get started to start preparing our data. So we're going to be accessing some data from different data sources, and we're going to be using these drag and drop blocks in order to do something. So I'm going to start off by just kind of giving a bit of a tour of the interface. So I've got my kind of main workflow builder here in the middle. I've then got some operators here over to the right. So this is kind of a folder where I can access all of that functionality. I've also got access to some assets. So this is what's already in my project, which I'm going to kind of reuse as I go. So we can kind of see here those connections that I showed off earlier and some of that data I've got access to. And then we'll be setting some parameters on those operators as we go. So what I'm going to first do is I'm just going to drag on a CSV here. It automatically here creates an input for me and connects it up for me, which is really quite helpful. So I've got access to my CSV. But I then need to do something with it. So I want to read a CSV. So I want to use a read CSV operator. So we can find that here in the data access, but I've pre-saved it in my favorites just to make it a little bit easier. So I'm going to drag on my read CSV. It'll connect up, and I can then configure the parameters that it's jumped to. In this case, I kind of know that it's already pre-set up, but equally I could be changing something like the column separators. We'll click run up here at the top. So what it'll be doing now is going and fetching some resources and then running this workflow for me. Obviously very simple in this case, but we can see here we've already got that message to tell us that it's finished. And if I click on read CSV, I get the results down here at the bottom. So I've got a nice data chart so I can see my data. Let's just make that a little bit bigger as well, so it's a little bit more visible on screen. So I've got my data. I've made it accessible. Now let's take a look into it. So always a good place to start is some statistics. I'll click statistics here down here. And then I can see things like for my different columns, the data type. So I can see here I've got an integer value for my reach. So this is robot arm data. I can also see I've got things like robot type, power, base, which plant it's based in. I can see I've got some missing values here, which we'll come back to in a bit. I can see I've got some supplier information. I've got an order date, although I do notice that's called polynomial, which is what we kind of refer to as category data. So we probably want to fix that, which we'll do in a second. But I can also do things like chart my data. So we get some charts here in our statistics view, but I can also go to my chart pane here, and maybe I want to create some form of scatter plot. So maybe just something simple like reach versus weight, perhaps. Quite a simple one. And we can see here we've got some categories for our reach, and we can kind of see a distribution in terms of the weight of those arms. So we can really explore our data quite a lot here. I'm probably, just for the sake of time, going to gloss over that a little bit, but there's lots we can do here in terms of charting and chopping and changing the data in different ways. So as I mentioned, on this statistics view, we noticed order date was the wrong type, so we need to fix that. So what we're going to do, I'm just going to make this a little bit smaller again, is we need to add a new operator. So we need to do a new action. We're going to use a new operator. So what I want to use here is a nominal to date, because I want to convert from a nominal type to a data type. So I'm going to drag that on here and click. I can see here I now need to set up my parameters. So we're just going to fetch our column headers. Just taking a second. There we go. I've got my order date, which is the one I want to convert. We then need to choose the format. So we're trying to say this is the format you need to look to convert with. So in this case, because I've already had a look at the data, I know it's this one here. But if we did want to check, we could always just go back and have a look at our data and see that it is indeed this format. So I've got my nominal to date, and let's click run and see what that does. So it's now going to run this operator for me in the background. And what we should find is that in a second, we get that result. There we go. And if we have a look at statistics, we should then see, if we scroll down, that order date is now classified as a date. And if we have a look at some of the statistics that it's producing, we can now see it's calculating more reasonable things for a date column. So things like the earliest date, the latest date, and the duration there. And perhaps that's actually showing us maybe we've got some outlier data here, as it does seem perhaps you haven't got a machine from 1994. But of course, you can do that with more explorative analysis. So let's do a little bit more. We need to still clean up our data before we bring in more. So what we're going to now look at is our missing data. So we see here in our plant column, we've got some missing values. We need to kind of fill this in. So I could add another operator, but let's start using some Gen AI. Let's help ourselves out. So I'm going to make this this port active. And then I'm going to ask a question. I just want to say, I want to remove missing values. Now, as it happens, have I misspelled something? No, that looks fine. So let's send our query to Copilot. And we see here that I've sent a user query and it's given me a response. And it's also using the notes functionality within our Copilot here in our workflow builder in order to show what it's done. So it's added in this replace missing values operator. Now, I can have a look here. And in this case, I haven't been really very specific with what I want to do. So we want to just configure this a little bit more. So I'm going to say, in this case, it's actually a single column. Again, we'll just go and fetch our column names. There we go. So it's the plant one this time. And we want to replace it with a value. And in this case, I happen to know that the missing values we want to replace with Ohio. Again, of course, we've got lots of different options here. If you want to replace it with a 0, with an average value, with the most common value, things like this as well. So I've set this up as I want, and then what I'm going to do is just set in an output just to see that result. So we'll just add that in there. I'm going to turn off saving results. So we'll hit play. And again, now it's going to be running this operator for me and replacing all of those missing values. So now if we have a look, we can see for plant, those missing values are now replaced with Ohio. So what I think this shows is also the value of using things like these low no code workflows, because in a very short space of time, I've added 3 different steps. I've read my CSV, I've converted some data, I've replaced some missing values, but I can still go back and see all of those individual steps. I can see what happened after here. I could go and change something. I could remove this step. I could change where I was getting the input data from. So all of this is reusable, but it's also very auditable. So I really can track everything that happens with my data. It's not all just kind of trapped inside individual calculations or pieces of code. Let's show something a little bit more specific though with that Copilot, because maybe that was a little bit generic. So again, I'm just going to set this port to be the active port, and I'm going to say I want to rename plant to factory, and I'm going to send that off to my Copilot. And we can see here it's now added in a rename operator for me. And if we have a look, it's also done plant to factory. So that's really nice, just supporting the user if perhaps you're not as familiar with this kind of RapidMiner interface. So we've prepped this kind of first CSV. That's great, but we now want to bring in more data. And obviously, we don't just work with Excel, so we actually want to bring in a database. So what I'm going to do first is I am going to add in my database connection. So I've just gone up here to Assets, and I've added in what we call a Postgres connection, which is a type of database. And then I want to add in an operator, which is called read database. So I can drag this on and connect that connection through to my connection port. And then I need to configure what I want to read. So I could write a query, and usually this would be in something like SQL, which is a query language for databases. But I can also just say I'd like to read a table. So I can then fetch the names of the tables, which I've just done by clicking that button there. And then I get access to all of my different tables inside my database. So I'm just going to select my robot arms usage table. And if I now run this operator, we can see I get this information out of my database. So I can see I've got some notes about potentially some failures. I can see its usage, some report dates, information about hours in service, things like this. And I've also I've now got this column called breakdown, which is telling us whether or not that robot arm did break down at some point. So we'll be using that later on for when we're trying to build some of those predictive models. But first we need to join this data together. So we go back to our operators and we're going to search for a join. And we kind of see the different options there. If maybe this is too many, we can have a look in our basic folder, which is just a kind of slightly simplified setup. So I'm going to join in, bring in my join. It could be left or right, but I'm just going to change that and bring that in as my right port. This one is my left port. And then I'm going to configure my joins, so we can choose if we want to remove our double attributes, but otherwise the only thing we need to do is set up what are our keys, which is really another way of saying what matches in one table to another table. So if you've ever done a kind of VLOOKUP in Excel, this is very similar. So I say from my left side, let's go and fetch our column names again. And that should just take a second. There we are. And I know it's robot ID. And then on my right side, we know it's also robot ID. So if we run this step, what we find is then we've got this join table. And just to emphasize again, we've now got 19 columns in our output, whereas we brought together two tables, this table with 10 columns, and then this table also with 10 columns. So we now have a much wider table with lots more information that we can use to build dashboards, to build reports, to build predictive analytics. So we've probably done quite a good job for now. So let's save what we've got. So I'm going to go back to my operators and I'm just going to save it. So I'm going to click output and I'm just going to choose where I'm going to save it. So let's save it overwrite this cleaned data entry, and we'll just click run. And that's now finished. So we've kind of finished our first phase here. We've taken two different data sources in this case. We've built this nice visual workflow where we've cleaned some data, we've joined it together, and now we want to make it visual. We want to build a dashboard. So let's go back to our project, and we're going to go to our files view. And we can see with this clean data, the last change was a few seconds ago. So I'm going to click on that entry now. And again, we get a similar view to us down the bottom inside of our Workflow Studio. So we get the data, we get the chart, we get the statistics, but we can also send it directly to our dashboarding tool, Panopticon. So I'm going to click Open in Panopticon here. And what it's going to do in the background is set that up for me. So it's ready to go, ready to dashboard. So I can see here it's opened it up inside my dashboard. I've got my data table ready. I'm ready to build a kind of final dashboard I can then share with my colleagues. So I can click and drag to create a visualization. You can see here a number of different common visualization types that we might want to create. We can add legends, we can add filters, we can even make this a little bit more dynamic. So build in actions where users can fill in information or they can click through certain pieces of data. But let's start with a table. Everyone understands a table. So I'm going to create a table. I'm going to say that every item is identified by my ID column. So there we go. Let's add in a few more pieces of information. So let's add in our base, maybe the factory, the power, robot type, usage, weight, and then let's add in maybe the breakdown status of it as well. So we've added in a table, perhaps not the most exciting, but let's make it a little bit more visual, a little bit more appealing. So we can add in a theme. So maybe let's change to our RapidMiner theme, which just adds in a few nice pieces of bounding and also changes the color scheme in the background. On the mention of color, let's add in some colors just to make sure that the eyes are attracted to the important piece of information. So we can drag this breakdown over to color. And then we could say, let's just change that. So when it does break down, it's more of a red. And then on our records, we'll select breakdown, and we will say that we're interested in breakdown, and it's going to automatically apply in the background there for us. So we can now see those rows where it does break down. Maybe they're grouped around certain things. Let's also add some filters, just because maybe we want to drill down a bit into our data. So again, drag to create a new part, select a filter box, and let's do it by factory and by robot type, let's say. We'll keep it quite simple. And again, we can configure these. So at the moment, they're just check boxes. Perhaps you want to do single selection. Maybe you want to do a free text field and so on as well. So lots of options there. Let's add in a few charts as well, because we don't just want table data. So I'm going to add in, let's say, a pie chart. So this time, our items are going to be based off breakdown. And for the size, we're going to do robot ID. So we're going to count the distinct for each robot ID, so just avoiding duplicate entries. And then again, we'll do the color setup. So we'll just set that to yes. And then let's also just add on our labels. So for color, we'll just add that on the visualization, so we can see our yeses and nos. We also probably want to make this filterable, right? So we'll add in a color legend, and we'll link that to our pie chart. And we'll also enable some filtering there. So again, I can filter via a legend instead if I'd like. Last thing, let's add some bar charts, just again for people to easily consume the different information. So we'll click and drag, and we'll create an x-axis graph. And then let's see what we're interested in. Maybe let's say that it's robot type we want to break down for. So we'll drag that on so we can see that's filled my x-axis. Y is again going to be robot ID. So we've got that Y, so we can see the different counts. And then breakdown, we're going to drag here onto the color pill. We'll change our yes to be red, just to be consistent. So we can see here the kind of different proportions, and it's a pure count in this case. So let's do something a little bit more interesting. So we'll change this to be percentage of parent, just so we get a more of a proportional view. So we can actually see, despite being many less, this SCARA one is in fact it has a very similar number of breakdowns proportionally to articulated robot types. So maybe we need to look into this a little bit more. So that's a little bit on charting. So we've kind of built on top of that data preparation that we've already done. We've now built some visuals, and I could then choose to save these, and then I could share these with my colleagues, so they can take these and they can consume this information that I've now built for them. And of course, it would be a little bit more pretty than I've managed there in those couple of short minutes. But now let's go back, and we want to start being predictive. We've done maybe the descriptive analytics, but we now want to predict what's going to happen in the future. So I'm back here in AI Cloud. I'm here still with my data set, and I'm now going to click Open Auto AI over here in the right. So this is a shortcut to our automated analysis, where you can do a number of different things. So what we'll be doing is auto machine learning, where we want to predict the values of columns. We're bringing historical data to predict what's going to happen in the future. But we also have auto clustering, where we find groups in data, feature engineering, where we can improve our machine learning models and finding kind of patterns and extra features within data. We've also got auto forecasting, so especially when you're working with time series data and wanting to predict that trend as it goes through time. So I'm going to go here to auto machine learning, click here, and continue with my selection. I'm going to give it a name, so I'm going to call it Auto AI Demo. We're going to give it a number of CPU, and I'll be a bit greedy and go for the maximum here, and similarly for memory, and click OK. So we then need to pick the column that we want to analyze. So I'm going to select in this drop down here, breakdown, which is here. So it's just going to analyze that data for me and then present me with a chart and the distribution of that data so I could see if it was particularly unbalanced. And we can also do things like define gains and costs, which is maybe a bit more advanced, but particularly useful when it's really important that you predict a certain category correctly. And there's applications of that in things like very high value manufacturing or medical applications as well. This is really important. So I'm going to click next, and then I get some feedback on my input columns. It's telling me which ones the software thinks is good to use and which ones it thinks perhaps you should avoid, and the reason for that. So for example, this first column, base, it knows is highly stable, so maybe it's less good as a predictor. I'm going to click that on. Weight, it's done a quick mathematical calculation, said there's no correlation, so it's probably not going to be helpful, but again, I'll just turn that on. And then the next two, it's said as high ID-ness, which is really just saying this looks like an ID column, which we really shouldn't be used for prediction, so we'll leave those off. And report date then is also seen as highly stable. I'm also going to modify things a bit, so I'm just going to take out my other two date columns as well, just because I don't want to use those. So we'll click next, and we're now through to selecting which models we want to use. So we get a couple of presets here. We could be choosing very interpretable models because we want to understand what's happening. Maybe we want to do some quick prototyping. Maybe we want higher accuracy, where it's going to use some models that take a bit longer to train. And then we also get some additional options here on the right-hand side. If perhaps you're a bit more confident and you know what you want to do, or perhaps what's worked well in the past, you can then go into some advanced settings and see, I want to use this particular type of model, or I want to use this particular sub-option. I'm going to go back, and I'm going to choose the quick prototyping option just for the sake of time, and then we'll click Run Auto Modeling. So this is in the background, it's taking my data, it's building those visual workflows for me, and then submitting those ready to be solved. It's going to present those to me together in a quite a nice way. So from experience, this will probably take about half a minute just to solve. But what it's going to be doing is training these 4 different models that were kind of part of that preset. So we've got naive Bayes, which is a probabilistic model. We've got 2 more mathematical models in generalized linear model and logistic regression. And then we've got decision tree, which is really a set of nested rules, and we can think of it as. As part of those additional options, we could have also done something like weight analytics. So this is looking at the input column weights and telling us again mathematically which look like they have the most impactful kind of performance on the output prediction. So this should take just a little bit longer. But what we'll then be able to cycle through is our accuracy. We'll also be able to look at things like classification error as well. And then also get more focused outputs, things like precision, recall, area under the curve, and our gains as well. So hopefully this will just be a couple more seconds. Otherwise, I'll go back to here's one I prepared earlier. It's looking like it's taking a little bit longer today, so we'll come back to that in a second. And we'll just go back to my content page here and just open up, oh, that's actually the same one, excuse me. We'll open up one that I ran on Friday. So I'm sure by the end it'll show. But we'll see the results just so we get that similar view. So we can see here that naive Bayes, generalized linear model, logistic regression, and decision tree. And we get some outputs, so we can see here that for accuracy, our naive Bayes model is the best. But if we're interested in particular things like the precision, we can see that a generalized linear model is performing better, as is logistic regression. And in fact, decision tree was the best performing. So let's take a look at some of those models in a little bit more detail. So maybe we're interested in our naive Bayes. So I'm going to click that here. So we then get a breakdown of how it's performing. So it's telling us its overall prediction accuracy, how well it's done on breakdown equals yes. We get what we call a confusion matrix, which is a breakdown of the actual categories versus the predicted categories. So we can see here there's quite a nice spread of there. It looks promising in terms of its predictive capability, but perhaps not doing particularly well or as well when it is actually yes. We get this ROC curve, which is useful for telling us that distribution of true positive rate to false positive rate. And then we also get some particular insights. So this is a visualization for that particular model. And we'd get similar ones, for example, if we were interested in our generalized linear model. Again, we would get a different visualization. So it's a mathematical model, so we get out the coefficients. We can also then do some more fun things. So we can go to our simulator. So once we've saved our analysis, we can then choose our naive Bayes model, and then we can try out new values. So without having to actually perform a test, without actually having to get to that situation in real life, we can try out things and see what the model would predict. So maybe I'm trying to find out at what point it will predict that something should break down. So let's maybe up the hours per week to something like, let's change that to 60. So it's up to now slightly better. Let's increase the payload. We're nearly there. Let's massively increase the hours in surface as well. It's very close. And we'll increase the average hours per day. There we go. We just tipped over the edge. So we've now kind of seen that threshold for where it's going to start to predict breakdown for us. So we can use this as a bit of kind of what if trial simulation to find out kind of what's happening, what's going on. So we've now built our predictive models. We've got 4 of them here. I could open them up. I could save them. I could deploy them even. We've seen how we can work with that table data. So now let's dive into the next stage, which is working more with our free text. So as engineers, as I said, and I'm sure it's the same for plenty of other disciplines as well, we end up with a lot of free text. So I'm going to go back here to my content, go to my first page, and I'm going to start a new workflow studio again. And I'm going to call this text analytics demo. And I'm going to create and start. And it's again just going to be preparing that workflow studio for me. And there we go, it's opened up. So it's the same sort of kind of process as before, but we're kind of working on that notes column. So I'm just going to fetch that here from my assets. I'm going to grab my cleaned data that we had previously. And just while that execution unit loads, we'll just close down a couple of tabs at the same time. So once we've got our data, we need to do a couple of things to prepare it for text analysis. So on my operators, we need to declare that particular columns are text that we're going to work with. So I'm going to go to all, and I'm going to search for my nominal to text. And we're going to grab that on, and we're going to add that to our workflow. And then we're just going to say that we've got a single column that we're working with, and we're going to say that it's that notes column that we're analyzing, that we're going to declare as text. And if we just run that now, we'll see that data down here at the bottom in a second, which is declared as text. Which is this one down here. We'll see we've also got a few missing values, so we don't want to analyze empty fields. We'll also add in a filter. So I think I've got it pre-saved in my favorites. There we go. I'm going to filter out some rows, and I'm just going to build a quick filter that says I want my notes where they are not missing. So quite simple. We'll click save. We'll close that, and then we'll run it again. And what we'll find is that data will now be filtered, and those rows with missing values are filtered out. So there we go. Again, if we want to compare and we want to see the effect of that filter, I can click on my first operator. I can see I had just over 16,000 rows. after this second one, just under 4,000. So we've got our data ready. Let's now do some text analysis. And what we want to use here is a particular set of operators. Is called process documents from data. So it's this one here. So we're going to set up a loop effectively for every row. So I'm going to drag that on here. And I need to say what I'm going to do inside that loop. So we're going to click this little subflow button. And then we're going to build that subflow that we're working with. So we want to do a few things. And all of this is kind of part of the Altair training and the RapidMiner training of how you might approach this. But some fairly standard steps of, we first want to tokenize our sentences. So this is where we split them up based off some condition, so usually blank spaces. So we're splitting up our words into what we call tokens, our sentences, excuse me, into what we call tokens, and that's based on non-letters. We want to make it consistent, so we will probably want to transform the case. So we'll use this transform cases option. So we'll drag that in here. And then final thing, we want to look at stop words. And stop words are the sort of filler words that we use when we talk. So things like and, is, the, but aren't as necessary when we're looking at full-blown text analysis. So I'll drag that on here. Oh, excuse me, that was the wrong one. That's a dictionary where we can define our own, but I'm going to use the English default here just again for the sake of time, and drag that over to the output. So we'll go out and then we'll just have a little bit of a look at the settings on this loop here. So I'm not going to use create a word vector just because that creates quite a big table that we can then use for, again, predictive analytics. And I am going to choose to keep my text. So we're interested in the word list output, so we just want to make that visible. So I'm going to use word list to data, data, and drag that on. And then we'll just also put an output on that there. So we'll just drag that over to here and connect that up. There we go. And we'll turn off save, and then let's click run. So in the background, oh, excuse me, that's just gone for the wrong type, wrong input output word list, excuse me. So I've got some feedback there that I've connected the wrong port. So we'll redo that again and connect it to the right place. Click rerun. We now see that error has disappeared. Our process documents from data is completed successfully. And then if we have a look at the output, we can see that output where we've now got a table for every word that was in our collection of input sentences, the total appearances in documents, and then the kind of final total, so accounting for multiple appearances. And we could even add in a sort here as well, maybe just to make this a little bit more interesting. So we'll drag that on and we'll add a sort, and we'll just say that we're interested in total and we want it to be descending, and we'll just click run there. And there we go. So we see the most commonly appearing words. So arm failure, probably not surprising given we're looking at robot arm failures. We've got things like gears, which look quite common, mechanical issues, due, joint, further, resulting investigations, and so on. And probably, again, if we had time, we would look into using some sort of dictionary to filter these out as well. But let's try and do a bit of sub-analysis. We want to see if there's maybe some sub-issues hiding within our kind of total set of breakdowns. So I'm going to go back to my operators here, and I am going to search for topics. And what we find is we've got this operator here, which I'm going to drag on and just connect it up to where I'd like it, which is here. And what this does for us, if I just select the column I'd like it to run on, is it runs a particular method to try and find where these words kind of naturally group together, almost kind of like buckets them up into separate topics. So I can use this to see if maybe there's some subgroups within my data. So I'm going to start off by looking for maybe 10 groups, and I want the top 5 words between each of those. And if you want more information with all of these operators, there's always the help available as well. So it's giving us a bit of feedback as to where that's found. Just for the sake of time, we'll just see what the result of this is initially. But what you would then generally do is do some kind of loop analysis, where maybe you're going to first remove all of those stop words to see which ones are common we're not interested in, and then maybe you might play around with some of these parameters as well to find what's the best number of topics to look at, what's providing you with the most kind of impact and information. So what we find, if I just add, let's just have a look at the topics output, is we see here that for topic ID 0, top words are things like seal, joint, leak, revealed investigation, and then so on and so forth. So for topic ID 1 is just mechanical investigation by the looks of it. Maybe number 3 is gear failure, and so on and so forth. So we can use this for some topic analysis. But this is maybe what is now termed as traditional text analysis. We've obviously got Gen AI as well. So let's start using that. So I'm going to go again back to my project view, and I'm now going to create a prompt studio. So prompt studio is where we can start to play around with generative AI prompts, and we can start to access real data. So I'm going to create a new one, and I'm going to call this maybe text analysis Gen AI. I'm going to select my LLM connection, create and start, and we get a few kind of templates to get us started, but I'm going to go with a blank option, and then we give it a set of prompts. So it's a bit like ChatGPT. It's very simple. We say summarize this problem. We want some text to use, so let's just go back to my files, have a look at my data, and we'll just get the first set of data. Actually, I'll go back just because I've got the example comments saved separately, so it's probably just a little bit more useful to use. And it's just loaded that data in, and let's just select all of that. I'm just going to copy that, and now I'm just going to paste it in here. There we go. So I can then test my prompt. It's going to call my LLM in the background, and is then giving me a summarization. That's great. It's a starting point. I can now iterate and improve upon this. So maybe I want to play around with my system prompt, which is usually hidden from that kind of final end user. So maybe you are a helpful engineering assistant. Summarize text with a maximum of 5 words because we want it to be brief. And we can test that prompt. And it's given me robot arm failed from where. Great, perfect. I can also play around with things like parameters. So maybe those of you a bit more familiar with generative AI, we can try things like the temperature, which generally controls how variable the response is. So I could ramp it up to 2, and I could test my prompt. And I can see I get an output. If I test again, and I can see I get a different output. And I could even go the opposite way. So we'll go down to 0. We'll test our prompt. So robot failure caused robot shutdown, and we'll do it again, and we see we get the same output because we've now changed the temperature to be 0. So that's good. We can even do things like comparison, but we want to use this maybe for text classification. We want to find those sub-issues. So what we're going to do is we are going to change our system prompt a little bit. We're going to change it to classify this issue into joint failure, gear failure, or other. Only, excuse me, return the chosen category. So we're saying what we want it to do. We're then going to change our user prompt, and we can again test this, see what it produces. It's produced gear failure. That looks promising. So let's bring in a bit more data just to check that this is working. So I'm just going to take that data away. And what we can now do is bring in variables. So I'm going to choose my input variables and choose a data set. I'm going to use my example comments. Well, I can choose some sampling if it's a particularly big data set. So we'll go for 50% and we'll say it's an input. We'll click add. And then we will add our data in here. So we'll click add input. We can add in our data and then we can test it. And what we will see is it then takes that data set from my catalog and it now runs that prompt on all of that data, which is really nice. Now I can see how it's going to be performing on a larger test set of data. So I can see the input and then I can see the output. So I can see some gear failure, some joint failure, some other as well. So I can see how it's well performing. I can give it rankings as well, things like this. But the really big advantage here is we can now link back to those low no code workflows. We can make this productionized. So I'm going to save this and I'm going to say production ready. And I'm going to click save. And then I'm going to click use. And what this does is then it generates a workflow in the background for me, which I can then link into my cloud data storage. I can link it into my databases. So I'm no longer just working with a chat interface. I can now turn it into an automated, even a deployed workflow that's applying generative AI to my business applications, which is really powerful. And again, I've not had to write a single line of code. So it's generated exactly what I had there, my LLM connection, my input from my catalog, it's got my sample, it's prompting with my data, and it's using that Prompt Studio object. So what I can then do is go, I want to replace this input, which is my example comments. So let's remove that. And we want to add in our database connection again. We want to add in our read database. So we'll just connect that in. And we know that we want our table. We want our robot. We'll just wait for that execution unit to load. But we'll also add in, while we're waiting, we'll just add in that filter rows, just because we know we'll want to filter where there's only notes available. So I'll connect that in. So just to set the rest of this up, we'll check our database, and we'll get our column names, our database names, excuse me. So we'll get our robot arms usage. We'll then set up our filter rows where we're only interested where our notes is not missing. So we'll save that and we'll close that. And again, just for the sake of time, I'm just going to keep in sampling. So let's do an absolute number of 50, just because we want it to be nice and quick. And then we'll add in an output just so we can see that response. So we'll have a look at the result here, and we won't save our results and click run. So we're now applying that generative AI to the data that was in our database. So I'm prompting with my data. And what we'll find is in a second, once it's run those 50 examples for me, we'll have that output available. So we can see here, I've got that note, but then I've now got this far right column. If I just expand that up a little bit with my results, I can see quite a lot of gear failures for the example that we had. Maybe we want to chart that as well. So we'll do a pie chart and we'll group by result, and we will do it by robot ID, and we'll do it by count. So we'll see the vast majority are gear failures, some are joint failures, and then there's one other. So we've used Gen AI to classify text, we've applied it to data in a database, and we're able to get further insights. We've made generative AI value add in this case. So I think by my count, I've slightly run over, but we'll still kind of carry on. We'll show that final step of now how can we build agentic AI solutions and applications. So what I'm going to do, just go over here, is I'm now going to create what we call an AI agent, and we're going to use what we call Agent Studio, and I'm going to call this Operator Assistant. We'll click Create and Start. So this is just creating a new instance of Agent Studio for us. I've already got one running here in the background in case we'll just jump over to that if we need to. So that's just starting in the background. Give that a second, otherwise maybe we'll just jump straight into this one here instead, just 'cause we've got that already launched. So I can create what we call a new flow, and we have a bunch of templates that you can use in order to get some kind of insights, get some ideas to get started. But I'm going to use a blank flow just because we're going to show building an AI agent from scratch. So I've got this blank canvas that I can use. And what we're going to start doing is adding an agent. So I'm going to drag this on here. I'm going to change my LLM. So an agent, tools plus LLM. So we need to choose our LLM first. So I'm going to use my Azure, and I've got some pre-saved variables here just to speed things up a little bit. Excuse me, that's not right. There we go, deployment and endpoint. So I've got my agent, and then we'll give it some inputs and outputs. So we'll give it a chat input, and we'll give it a chat output as well. And we'll click playground just to have a bit of a play around, and I'll try my usual test, which is tell me a joke. So hopefully the LLM is able to process that, and it's given me one, and I could always test its capability as well and say, tell me the same joke in German. And someone will have to double check that for me, but hopefully that looks about right. So we've got our kind of base agent set up, but we now want to give it capability. We want to give it tools. So we've got this tools input, and we've got some pre-built tools already available. If I want to expand those, we'll just collapse these down now to make it a little bit nicer. So why don't we give it a Wikipedia tool? Quite common, quite useful. You're able to search the web, so we'll connect that in. And then a common one probably, we want to be able to do calculations, so we'll bring in our calculator, and we'll turn on tool mode, excuse me, connect that in, and then let's start again, and we'll just create a new chat, and we can always just ask it to see if it's using that tool effectively. What is 5 times 25 plus 13? I'll see if I can work it out in the background. Is 138, which hopefully is correct. And we can also trace back through to see what it was doing if we want to. So hopefully demystifying AI agents a bit, it's LLMs plus tools. We want to link in with everything else that we've done. We want to start adding some extra capability in here. So the first thing I'm going to do is give it a document that we want it to talk over. So it's operator assistance, remember, that we're trying to do. We want to give it the documentation that we're working with. And one thing we could do is use something called RAG, or retrieval augmented generation, where data is stored in a vector database. But also we can maybe keep it a bit simpler for this one here, where what I'm going to do is I'm going to load a file from my data catalog. And in this case, it is a Word document. And I will just double check my notes for what it's called. There we go. So it's called Comprehensive Robot Arm Repair Guide. And we can double check and just click play to see if that runs. And it looks like it's running correctly because we've got a little green tick down here in the bottom left. So now what we need to do is we need to pass that file that we've loaded in. So we'll drag on a parser, and we'll drag in our data, and we're just going to what we call stringify it, so turn it into a big string. And then finally, we want to build a prompt. So I'm going to drag in my prompt little card here. So we need to type a prompt, and we'll say you are an engineering assistant providing concise operator support, leveraging tools and documentation. You have access to the following document. and then we'll add in a variable. So this document, which we can then use, and then we'll say, here's our question. We'll click check and save down here in the bottom right. We now see we have this input port for our document. We can connect in our parse text, and then we can add that into our agent instructions. So we've quite a simple way, but we can provide then a document to our agent. Again, we can go back to our playground. We'll start a new session, and we'll just say what different robot types are in my document. We'll send that off. And there we go. The document lists the following types of robot arms. So it's able to search through that file that we've provided it there. So nice, we're able to start chatting with our document. But the final thing is, of course, we want to provide it all of that lovely other data analysis tools that we've built. So we want to add in one final tool. So if I go here to my AI cloud and I'm going to call a workflow, and we'll just spread things out a little bit more just so it's a little bit easier to see what's going on. So I've got this cool workflow, and we need to select a deployed workflow. So I'm just going to refresh my list, and I see I've got one deployed, which is very similar to that first workflow we built, but it just returns the latest robot arm failure. So again, we'll just select our endpoints, and we've got one there. And then I need to copy in what we call a secret, which is a bit of authorization. So it just makes sure the agent is allowed to access it. We're going to then turn on our tool mode. And then finally, we need to describe to the agent what that tool's doing. It needs a bit of help. It needs some instructions. So here we're going to change this description here. And we're going to say it is use this tool to fetch the latest robot arm failure, use the following input, and then I'm just going to give it the format for an empty input, as our deployed workflow doesn't need any input, so it's just a empty JSON schema. And then I think we're ready to go. So we'll close that down. We will give it our agent, our tool. We'll again click playground. We'll start a new chat, and then we're going to have a go in one. So tell me how to fix the latest robot arm failure. And it all being well, what it should do first is it should go and fetch the latest robot arm failure, which I can see it's doing there. It's executing that. So it's telling me what the latest robot arm failure is with ID 3. It's in doing assembly task in the Michigan factory. It's telling me why it's failed, and then it's got the repair steps from the document I provided it in order to provide that operator assistance. So we have built our first agentic system all in the space of about 10 minutes. So with that, just to close, kind of what we've seen there is obviously a few different steps on how we've connected to different data sources. We've prepared data, we've visualized it. Hopefully, you've seen how easy that is, and then how we can build upon what we've already done to build predictive models, to use generative AI, and finally to build AI agents. So I apologize a bit for overrunning, but hopefully we might have a few questions.
Awesome. Thank you so much, Roland. It was a little bit longer than expected. By the way, the joke in German was not that funny, but it was more funny in English, though. But yeah, okay. It was translated correctly. I have one question, maybe, Roland. And I mean, you can connect to any tool, so it's kind of tool agnostic, the AI agent that you've built. Would you also be able to hook it up to FEA or CFD tools?
Yeah, certainly. So I've had a bit of a look at that myself, and certainly you can see some of those standards that are kind of approaching the market, where you've got things like MCP, so more kind of common protocols that are connecting up. And when we can do things like call MCP servers, so certainly you can connect to different tools. Usually the only barrier is IT, but certainly the technology is there.
Yeah, I think that would also cover the next question. How do I integrate RapidMiner models with external applications such as ERP or CRM systems?
So it depends where you want to combine it. So either you might bring the data into RapidMiner, into one of those workflows I already showed a little bit like this, or we also can go the other way as well. So we have something called deployments, where we can deploy our workflows as web services, and those can be inside your CRM or something like that as well.
Mhm. And the next one, which machine learning algorithms are pre-built in RapidMiner?
I think the number is in the region of 70 odd. I would recommend looking at our documentation. Usually they're things like math-based models, tree-based models, ensemble, deep learning as well, things like this. And then it's even more extensible if you want to include Python, which is very easy to do as well.
And then maybe we have a last question before we wrap it up. How do we actually get started with RapidMiner?
So I'd recommend taking a look at the Altair website. So there's loads of links there. We also have an online e-learning platform called the RapidMiner Academy, where there's loads of self-paced training that you can take. There's certifications as well that you can use. So I recommend those are a good kind of couple places to start if you're really interested.
Okay, we'll share the links with all the attendees after the session. Roland, thank you so much. I know it took a lot of time and also coordination from your end. So thank you very much. And then if people have any more questions, they can reach out to you, hopefully via LinkedIn, if that's possible.
Perfect. Well, thanks very much for having me. I hope everyone found it very interesting.
Absolutely. Thanks a lot.
All right. See ya.